Hi, welcome. We're glad that you're here to join us today for our science experiment. I'm Michelle with Colorado Model Railroad Museum.
And I'm Mistie Trefry with the Colorado Model Railroad Museum. And before we get started, we'd like to thank our sponsor for the video, Greeley Station, who is streaming this live. The mission of Greeley Station is to connect businesses, organizations, and individuals through their live streaming. Thank you for tuning in today.
Yes, thank you. And if you're watching this live, you can ask us questions right here on the live YouTube stream, and we will answer them live if we get them. So otherwise, you can ask them in the comments later after this is posted, and on Facebook. So wherever you're accessing this, there's a way to comment, and we're looking, so we'll answer your questions.
We have a laptop right here to pay attention to questions.
So this is a series on energy, and the first one we did was about potential and kinetic energy. And then the next one was about different types of energy, kind of the whole gamut of all the kinds. And today we're going to focus in on electrical energy and mainly static.
Yes.
We're going to do some static experiments. So what is electrical energy? It's all about charge, right? So everything, like this pop can, has a positive and a negative charge in it. Everything in your world has positive and negative, protons and neutrons, and they have charges. And so what happens is when something gets more of one or the other, it becomes positively charged or negatively charged if it gets an imbalance and has more of one than the other. So when you have positive charge and negative charge, they want to go together. But if you had two negative things or two positive things, they're going to repel.
It's kind of like magnets, right?
It's just like magnets.
So if you have a positive and a negative side of a magnet, it's going to stick together. Where if you have two negatives, they don't
want to be
struggle
together.
to get them.
Yeah,
it's like
right. The positive and negative is like that. So they want to attract to each other. So that's what we call charge. That's that positive or negative side of things. So what is current? Current is kind of how it moves. So current is when something has more of one charge or the other, which causes movement.
Yeah, it's kind of, so that movement can be, for example, like when you throw a stone in water, there's a ripple effect. Remember, electricity is a type of energy that can build upon and flow from one place to another.
And so think of it almost as like that ripple of water, but it's a ripple of basically positive charged energy, electrical energy. And so what happens is it moves from one to the other. Now, there are things that conduct electricity better than others, and one of the best ones is metal. So you'll often find that wires that conduct electricity to your home are metal. And then it goes through the gamut of all the different kinds of substances, and rubber is like the least conductive.
Right, because that kind of stops the
charge
flow,
from going through it, right?
Yeah.
And so metal is one of the most popular. And so I thought I would explain how model railroading works, because actually, when you have track, there's metal here. And this metal actually conducts the charge. So when you build a layout, what's called a DC layout, and you have a little throttle like this guy, and he's got power in here. When you turn him on and you turn the handle, you're putting electrical flow of current into the track. And that's why the train moves. It gets the electricity, and the more you give it, the faster it goes, or you can slow it down and it'll stop. I don't have it live, but that's how it works. It's kind of cool.
So that kind of controls the flow of the current, electricity current. Right. And that's where that movement comes in. That's interesting.
So it gives it more or less. So that's how model railroading works. Okay, so let's talk about static electricity. Static electricity is when something has a whole bunch of, usually negative, built up in it, and it's looking for a ground or something positive to get to. And so there's a lot of fun things you can do with static electricity. And so we're going to do a few different experiments. One that I'm sure that you've seen before is when you run around your house in socks on your carpet and you rub your feet in the carpet and you touch someone, what happens?
Oh, there's a little shock.
It goes, yeah, that's static electricity. Because you're charged up. So when you rub one material against another, a lot of the negatively charged particles will move over to the other thing. And so one has an excess of negative charged particles. Now, the easiest way to see this is in a balloon. So we're going to do some experiments with the balloon.
So we have an already blown up balloon, and Michelle is going to blow up another balloon.
But I learned a lesson earlier today.
What did you learn, Michelle?
I learned that your balloon shouldn't be huge when you blow it up. It should be more like the size of yours. Because you can't hang on to a big balloon. Do you know how hard it is to hold on to this?
Oh, that's right. If you're holding on to one hand and you're trying to build up your charge.
Exactly. So don't blow it that big.
All right. So
I have another one here. I'll use this one that I blew up a minute ago. So go ahead and blow up your balloon at home and tie it off. Make it about so that you can hold it in your hand.
Right. While you're blowing up the balloon, I just want to say we have some viewers out there. We've received a lot of feedback and are very thankful. We welcome all that feedback. We enjoy your pictures and everything.
Thanks for sharing all of your experiments at home.
I love it. We have 3-year-olds talking about potential energy and kinetic energy. Thank you, Trent. We're getting lots of videos and feedback, and so if I can, I want to shout out to some of the kiddos, Trent and goodness gracious, I'm sorry, Emily, Hunter, Arden, Trent, I said Trent, Hannah and Katrina. We really do appreciate all of that. Keep things coming our way. We're very excited that everybody's learning. And it's so much fun to learn when you get to play with balloons and all this other stuff. Rubber bands helping make potential energy, that kinetic energy. So this is all great.
Okay, so
here we go.
We're going to do an experiment. The best, easiest way to charge this up that's always at your disposal is your hair. But I'm not going to do that right off or my hair's going to go, so we'll try it last. But there's another easy way to do it. And that is grab any stuffed animal in your home that has fur.
Okay. I'm going to take one for the team. I'm going to try my hair. I'm going to try my hair. I didn't condition today just for this.
So you're going to grab your balloon and you're just going to rub it on this surface. I can already hear this popping.
Oh, I hear it.
Do you hear the static popping in there?
I do.
I think the synthetic fiber actually produces more static charge, which is why carpet is so good at producing
To my sister, I'm sorry if I ever hurt you and my static electricity rings I used to play on my sister.
I have a charged balloon. Something I know I can do with it is hold it in my hand like this.
Ah! Okay, I know
that's kind of fun. Another thing we can do is with a pop can. Empty pop can. So save your next soda can.
Yeah.
And we're going to lay it on the table and see what happens.
Okay.
So we're going to get this all negatively charged again.
Okay, I should keep going?
Yeah.
All right. Hey, did you hear the joke about the paper?
No.
Carl and Dean told me it was terrible. You got it.
That was a terrible joke. Okay. All right. So this is negative, right? We have a whole lot of extra negative. The pop can, like I said earlier, has positive and negatively equally balanced right now. So what do you think is going to happen when I put this near the pop can? Let's see. Oh boy, look at that. It's almost like the coffee cup racer, but a different kind. So what's happening is there's positive charge in that can that's attracted to the negative charge here. Remember, they attract.
Come on. Oh, I'd lose the race if we were racing.
So I think because the synthetic material charges so much faster off the stuffed animal. Should we try it one more time? Here. Okay, we'll do it one more time.
Here we go.
Ready?
Yeah, there it is. Woo!
It looks like you can do magic. I have a ripple in the tablecloth right here that's not helping.
Yeah.
So you get the idea, though. If you're on like a nice countertop, it'll probably really zoom across there. So there we go. Static electricity. Super fun stuff to play with.
Oh, she's got more static than I do.
Anyway, so the other thing you can do, which doesn't work right here, but you can also usually stick your balloon to a wall. Try that. Try different surfaces. Some things are more conductive than others, and you'll find what things stick to what. So that's it from me and Misty, but we actually have an additional video for you today, and you're going to find that link when the final YouTube post goes up, the link to our video about the Van de Graaff machine that Patrick made is really cool, and it's going to be right there under our video.
The Van de Graaff machine is so awesome. We look forward to having it into the museum later this year. And stay tuned, stay posted, because we'll be announcing when that will be, so you can come and get your charge.
Yep. So have fun. Thank you for joining us, and go watch Patrick Pulis' video with the Van de Graaff machine.
And we'll see you on Tuesday, 1 o'clock. Remember, tune in Tuesdays and Thursdays, 1 p.m. live. Thank you.
Thank you.